Hey everybody, welcome back to Young Engineers of Today. I hope you all had a good weekend. I hope you all did, interesting stuff. I'm sure since it's still early on in the semester, you guys aren't being, completely destroyed by homework yet, which is a good thing. But as I understand it, those of you who are in Charlotte got to play around with CNC machines this past lab. Those of you who are in Raleigh, you guys are actually just down the street, I believe, from ShopBot. Um, so that's pretty cool. But you'll get the opportunity to mess around with CNC machines in Charlotte in the upcoming weeks. I believe it's in the next week or two. At any rate, um, for that reason, on this side, we're going to begin the lecture portion of the CNC stuff. Oh, you mean the slides? Sure. I apologize. Yeah, normally I do this just because a lot of times I'm switching between different programs, and I don't have a second monitor to work with. But since a lot of the beginning stuff is going to be explanation, I could go ahead and do that. Let's see here. I just have to remember how to do that because I am not used to that. Duh. Or is that better? Were you just having a hard time seeing the slides? Okay, cool. All right. Yeah, I apologize beforehand. I'm not going to be able to do this all the time again because I'll be switching between programs a lot, but hopefully, you know, because the programs are going to be running on my computer, they might be easier to see than what I'm doing in the, or what's being presented in the slideshow. Um, but where I can, I'll do this. And you might have to remind me a couple times until I get used to the habit of doing it, but I'll do my best to remember. At any rate, um, I know I'm sounding very apologetic right now. I just wanted to lead this off with um, I'm not terribly familiar with CNC. I've been working over the last week to make myself more familiar with it, but I don't really have anything in the way of first-hand experience. So I'm going to, be as in-depth as I can, but it's the knowledge isn't all there yet. If you guys have any questions about anything, though, of course, feel free to ask me, and I'll, find the answer to your question if I don't know it. It's not like I'm going to sit here and go, well, I don't know. I'm working to learn this as well, alongside with you guys, and so we'll get this done together. However, the bulk of it is going to be Fusion 360, which I'm fairly familiar with at this point, so that's nice at least. Anyway, without further ado, let's go ahead and let's get started. So the subject of the next few presentations is going to be learning about CNC machines, how they work, and the bulk of it is going to be creating a project. Basically drawing something. So, yeah, like I said, we're going to go over a pretty brief introduction to CNC machines. We're going to talk about what you're going to need in order to work on this kind of stuff at home. And then we will introduce you guys to Fusion 360 if you're not already familiar with it, go through some of the basics and things like that, and then we'll get started on your first project, which is actually going to be a bookshelf. So, like I said, this presentation is actually going to take a few classes. It's not all going to happen at once, but once it's done, you guys should be pretty familiar with Fusion 360 and able to mill out basically what you created in Fusion 360, which is pretty cool. So, what exactly is CNC? Well, CNC is an initial. It's not an acronym because it can't really be pronounced. It stands for computer. numerical control. And that's the interesting thing about CNC machines. When people say CNC machines, you think of like a mill maybe, or a lathe, or something that does the work. However, CNC is a very broad term that refers to a lot of different machines, simply because the CNC part of it refers to the fact that it is controlled by a computer. There's no real human input on it. You tell it to build a thing, you give it the instructions, and it will build it. So for that reason, CNC machines can be mills, they can be lathes, they can be cutters, so on and so forth. They can be any sort of, machining type tool. The important thing is that the process and the machine itself is controlled by a computer, like I said, as opposed to human hands. Now, CNC machines are generally subtractive processes, which is different from something like 3D printing, which is an additive process. A subtractive process, you start with a chunk of material, and you remove stuff from it in order to create the final design. So maybe you start with a cylinder of metal, and it cuts out holes and contours and things like that in order to create the part that you need. An additive process, like in 3D printing, you start with nothing. In this case, a flat sort of canvas or template to work with. And then the 3D printer will melt down some plastic and basically extrude that in shapes in order to provide the whatever it is that you need, the model or whatever. So in that sense, this is an additive process. You start with nothing and you get something. With CNC, generally you start with nothing, or you start with something and you whittle it down to get something useful. So, yes, I know, it's full screen, thank you. Because CNC machines rely entirely on computer control, there is actually very little in the way of human input during the actual machining process. So when the machine is running, you can stop it, you can start it, blah, blah, blah. But once it's going, it's basically working off of the program that you gave it, in this case, the instructions. It's not like you're going to sit there and go, okay, go left, now go down, now start cutting, now stop cutting, now go back up. There's a computer that does that all for you. I think you guys get that idea. So instead, our input comes at the other ends with CAD programs, where we create designs in order to be milled or machined or whatever. But there are sort of indirect ways that we can affect the process. Whoops. Okay, so yes. Now, creating something with, what do I mean by CAD software? Creating something with CNC usually goes through 3 steps. What is the pin? We were at 3 different kinds of software. You've got the CAD software, which stands for Computer Assisted Design. These are programs that allow you to draw something on the computer in 3 dimensions. CAD software can run a number of different sort of categories, and we'll go over those in a minute. But that has the most user input. Yeah, no problem. I'm glad that worked out for you. Considering I've never actually used that feature before. So that's where you have the most user input, obviously, because you're creating your design. So it can look like, this is probably, I don't think it's SketchUp. Might be one of the more esoteric ones that's based off of, mathematical equations or something like that. Anyway, so those are CAD programs where the actual design is done. You can edit some settings there and things like that, but more often than not, you export your CAD design, your drawn whatever, to a CAM program, or computer-aided manufacturing. Usually this has some options where it asks you, like what bit size you're going to be using on the CNC machine, or how fast it's going to be feeding in the bit, or how fast it's going to be spinning, or how fast you want it to be moving, how many passes you want it to make, all that kind of stuff. You can affect those, which will affect the instructions to the CNC machine. Again, you're not really having direct control, though. That's sort of more an indirect way of affecting the machine. End result of this is what it does is it takes that 3D model, it generates a set of paths that the CNC is going to move over the material in order to generate your whatever you want to make. And then it turns it into a set of instructions, a set of text, well, code instructions that the CNC machine then uses. Usually these instructions are G-code. That is pretty much, if there was one, this would be the industry standard for CNC machines, 3D printers, all that kind of stuff. Any sort of three-dimensional additive or subtractive manufacturing. Then finally you've got the machine controller. So now the machine controller is like, you know, when you plug in a new set of speakers or maybe a network adapter, or when you put in a new video card or something like that, it asks you for drivers in order for the operating system and the computer as a whole in order to communicate with it. This is kind of like what that is. Essentially, this allows machine controller programs allow the computer to communicate with the machine. The most important part being the computer sending instructions to the machine and receiving information back from the machine so it can send the proper instructions, so on and so forth. That sort of thing, I mean, that works two ways, because you can work on dead reckoning, but some machines have the ability to tell you if, you know, something's gone wrong with it in some way or another. Most machines have to tell you whether or not, you know, like if the machine is stuck in some way or anything like that. But if it has the ability to communicate that back to the computer, then of course the computer doesn't need to keep sending it directions and can inform you and so on and so forth. But at any rate, at its most basic level, the machine controller is like drivers for the machine. Otherwise, it's not going to be able to speak the machine's language, and then you won't get anything, and that's sad for everybody, because then you don't have a cool machine printing out cool stuff for you or cutting out cool stuff for you. Now, this is, if you're running a setup at home or something like that, these are the kinds of programs that you're going to need. However, it's not always the case you're going to need all of these. Obviously, if you're taking your build to a third party, like a company that owns CNC machines, in order to get them cut out or something like that, they're going to have the machine controllers. On your end, though, you might need the CAD and the CAM software. Maybe they're high-end. Maybe they already have the CAM stuff, and all you need to do is make something in CAD and then send them the model, and then they turn it into G-code, and then they print it out or cut it out for you, whatever the case may be. So if you're running something at home, you would definitely need all three of these. If not, at the very least, you're going to need the CAD software. You might need the CAM software as well. Sometimes CAD and CAM software are combined, as we'll see with Fusion 360. So yeah, we already went over that. So CAD software it has a few different categories. It can be more of an artistic or freeform kind of software, so like Blender and 123D Sculpt Plus. These are the kinds of things that are used for, like, well, again, more artistic applications. So maybe they're making characters for a video game, or models for a video game. Maybe they're making models for a movie of some sort. Maybe it's like an art project where they're making a computer animated movie, or whatever. Regardless, this is generally less mathematically strict, so that's nice. It allows you to have a little bit more freedom in whatever you're making. On the other hand, it can be a little bit less bound by, you know, Euclidean shapes and things like that. Then you've got easy to use with some accuracy. Tinkercad, 123D Design, and SketchUp are very good examples of this, because they're still fairly easy to use. However, they do have, in some sense, requirements. Like you have to dimension out your sketches and things like that in order to be able to consider them valid sketches. Actually, that might be the next. That's the next one. Anyway, the measurements, scaling, things like that, so you can make sure that everything's the correct scale, but you don't by any means need to dimension out your sketches, and I'll explain what that means in a little bit. But these are still fairly easy to use. Um, a lot of them just involve sort of dragging and dropping or drawing simple shapes and extruding them out or whatever. And then you've got the more professional stuff. So Autodesk Fusion, SolidWorks, Alibre, these kinds of software programs, these kinds of programs, were made for designing, for engineering and designing. That means that they're more difficult to use, but at the same time, once you get used to them, they're very powerful tools. They allow you to do a lot of things, and they have a lot of mechanisms in place to ensure that whatever you're building, whatever it might be, is going to be accurate, is going to be to scale, and is going to be consistent. And it's going to be as accurate as you need it or want it to be. Of course, with limitations, it's not like we can take it down to plank length or something like that. But for modern engineering requirements, these are perfect. So they come from very free form to very regimented, and it may sound more intimidating than it actually is if you've actually used like Autodesk Fusion, and if you were in a class last semester, you would have used it. Maybe it was the semester before last. I'm starting to lose my mind. Anyway, it's not too bad. It's not too bad. We'll go over it. It's pretty easy. In CAM software, well, you got a few different options there. Obviously, you got a lot of different options there. But here are a few examples. You've got MeshCam, which works across many platforms. It's cross-platform, and it can communicate with many different types of CNC machines. So you can basically bring up the options for the CNC machine that you're using and get it up and running pretty quickly. VCarve is specifically for ShopBot. Other Plans is specifically for Other Mill, and I believe actually it's Other Mill that's out in Raleigh, now that I think about it. It's in Durham. My memory is failing me right now. And then the machine controller, you might have a custom machine-specific program. So you might have the ShopBot program or the Other Mill program, which are the specific drivers made by ShopBot and Other Mill for their respective brands. Now, the reason why we're talking about ShopBot and Other Mill so much is obviously because those are going to be the CNC machines that you're going to have experience with when you go in for the lab portion, if you haven't already. These are going to be the ones that you guys will be working with. So that's why we're singling these out specifically, is because these are the most applicable towards what you guys want to do, or what you guys will be doing, rather. Although you might want to do it too, who knows. Then you've got Mach 3 for Windows, which, much like MeshCam, will communicate with a number of different brands of CNC machine. But it's Windows only. And then you've got Linux CNC. Same deal, but Linux only. So, no surprises there. That all seems pretty straightforward, right? What about CNC cutters themselves? CNCs themselves. You've got a few different types, but let's go over cutters. You've got a few different parameters of cutters, so let's go over cutter shape. First, you've got flat end mills. Actually, I put the picture on the next slide. It's this one right here. True to its name, it's got more of a flat kind of end to it, hence flat end milled. Which is good for, bringing in more material and sort of cutting out things from the side and stuff like that. And then you've got ball end mills. Ball end mills, as I understand it, are good for basically entering directly into material. Like they work like a power drill in that sense. Flat end mills might be better for removing material, moving along the side of the material and removing it, like if we were to draw it relative to this. I'm so sorry in advance. Like if this were our material. A flat end mill would be like moving alongside it, or maybe it would be moving inwards towards it, but regardless, it wouldn't be moving down into the material, whereas the ball end mill would be moving directly into the material. Let's put it next to that. Certainly more so than the flat end mill would be. Then you've got flute length, which is that one I actually missed on. I'm guessing that's the length of the actual um, cutter that you're going to be working with. So that can affect the thickness of the material and how deep it can go in and things like that. Then you've got taper end mills. Taper end mills are a third type which rely more on, I guess, like a Dremel, just grinding things away. Now, another thing you're going to have to worry about with speeds versus with CNC machines is the speed of the basically of the bit, how quickly it's spinning, versus the feed rate, which is how quickly it's going to move in or out. So what would you need? What would be the correct speed or feed rate in this case? You would want to go with the recommended setting on either the other mill or the ShopBot, depending on which you're using, and use an educated guess. Obviously, there's no shame if you're not sure and asking a question, being like, hey, is this right? I just want to double check before I start drilling into this material. Because, it's not always easy to tell what the exact speed or feed rate should be. Obviously, you shouldn't be using an absurdly high feed rate or a ridiculously low speed or something like that. That's what they mean by temper settings with common sense. But it's not necessarily going to steer you, astray with the recommended setting on either the other mill or the ShopBot. So that more comes down to just sort of getting a feel for it, figuring out what might work, what might not work. Now, it is something to be careful with. I don't know why that's there again. Anyway, the speeds, rotational speed of the cutter in RPM, it is something to be careful with because if you have the wrong speed, you might break the cutter. You might have a rougher cut than you anticipated or wanted. You might waste time because it takes too long. You might have a poor finish because it's not actually shearing away material or cutting away material. It might more be tearing away material. In which case, that just overall looks rougher than you would otherwise have. So again, that's why you want to determine the correct speed. Now, feed rate is the speed the cutter is moving through the material, or the stock. The stock is another name for the material. Apparently these slides all have to be reordered because we're all over the place here. Anyway, yeah, in the end, just go with the recommended setting. Now, CNC machines can work with a variety of materials. They're not just metals. They can work with MDF, which is medium density fiberboard. If you've ever gotten like a piece of furniture from IKEA, chances are some of it is made out of MDF at some part. You've got plastics, different types of plastics, generally firmer plastics, wax for real, but it has to be machinable wax, which is generally a higher melting point and more sturdy than the kind of wax that a candle might be made out of. Foam for real again, but same deals apply. A stronger foam, more durable foam. Polyurethane tool boards. So the stuff like if you have like if your parents have a like a wall in their garage where they hung up a bunch of tools, or if you've ever been to like a shop, whether your high school has one or whatever, and they have that big wall where there's just a bunch of pegs stuck in and a bunch of tools hanging off of it. That kind of stuff is like a polyurethane tool board, at least nowadays, which is also a form of plastic, but it's a lot denser. And then metals, of course, we already knew about metals. Metals generally, at least in my experience, when you think of CNC, you think of them working with metals because a lot of times they're computer-controlled mills or lathes which cut through metals and make all kinds of neato, cool parts. That got moved around. Okay, so yeah, the software. Most software, we were talking about CAD, CAM, and machine controllers. Most software has at least a couple of these steps, CAD or CAM or whatever, integrated directly into it. So, for example, most CAD software will export directly to G-code after computing the toolpath and stuff like that, which is helps to skip the CAM step. But we're gonna go over creating something in Fusion 360 and also um, getting it ready in Fusion 360. So we will kind of skip the CAM step in a sense. We're going to be doing the same thing that CAM software will do. We just won't be using a separate program for it. So what we're going to do is we're going to create a simple bookshelf in Fusion 360, and then we're going to get it ready for milling. It's not going to be a crazy bookshelf. It's just going to be a squat little bookshelf that will be useful, but it's something that you guys will be able to make. So let's go ahead and let me give you guys the URL for Autodesk Fusion 360. I was talking about like a professional CAM programs or CAD programs, and Autodesk Fusion was one of them. This is what we were talking about. Autodesk Fusion 360 is a professional level CAD program. So let me go ahead and here we go. We're going to have, there's a 30-day free trial. So let me go ahead and put this into the chat. I believe it's at least 30 days. It might reset after some time. Mine's always said 30 days, and then it'll go down a little bit to like 25 or 22 days, and then it'll reset back up to 30 days. So I believe with at least every update, it resets. That's what I've noticed so far. So once you guys go to the website, you're going to go ahead and click on this orange button that says Download Free Trial. And it's going to ask for your email address. This time you don't want to actually put in your email address because it's going to email you information that you're going to need. I'm just going to use an old one. And then I agree to use my personal information as described in the Autodesk privacy statement. Of course, you can always review these if you're not sure. It's not necessarily a bad idea, but at the same time, it's understandable because, as I'm sure you guys are, anybody who downloads software on a fairly regular basis is probably going to run into license agreements left and right every single day. So it's good to at least get some sort of idea of what they're going over. But it's not life or death. Anyway, once you enter in your email address and click on Download Free Trial, it should send you to a new page. Here we go. Perfect. And it will download it. And then once it's done downloading, as you notice, it's only 4.7 megabytes. That's actually, it's downloading the downloader. So once that's done, then you go ahead and run it, and it will download Fusion 360, which is a pretty hefty program. I'm just going to warn you right now. Which, depending on how you guys' internet is, may or may not be possible to download by the time the lesson is over. So I guess in this sense what I'm going to do is I'm just going to give you guys a quick primer to Fusion 360. By quick I mean the last 20 minutes. So you guys know what you're getting into for next time around. But we'll save the actual, walking through of everything for this Wednesday. So don't worry about like having to remember everything that I go over right now. This is just so you get an overview of what Fusion 360 is like. So let me go ahead and get it open. it's going to say not responding for a little bit. Fusion 360, it's got some quirks to it. I'll just let you guys know that right now. Okay. Yeah, as you can see up here, term ends in 24 days. Again, I think the lowest I've ever gotten it to is like 20 days, and then it's always reset back up to 30. So, who knows? Anyway, this is what you're going to see when you first start it up. Not much there. Pretty unassuming. Now, you're going to have to create an account and stuff like that. We can go over that once you guys have it downloaded. I believe if we sign out here, we can take a look at that real quick. Yeah, you can just click on the signing up thing here and then enter in your information. Nothing crazy. But you will actually need an Autodesk ID, and that's free. You don't have to pay anything for that, but the reason you need that is because it will allocate Autodesk. They will allocate a little bit of cloud storage for you, and that's where you store your designs using Fusion. So you can pull them down onto other computers. You can share them with other people really easily, but it is something you will need. So let me just go ahead and sign in with mine. Boom. Okay, so once you've signed in, then you have something like this. Now, there are a few things to take into account here. You've got the intersecting axes right here. You've got the cube up here. You've got a few tools down here, and then you got a bunch of tools over here, actually, more than you might think. These are all different tools that you can use for building something. The first thing to really pay attention to is how to navigate around, because your life is going to be made a lot easier once you know how to navigate around. It's really easy, thankfully, if you just... Oops. Well, normally you can just... Alright, fine. Make a liar out of me. Well, first of all, you can hold down the middle mouse button and drag around in order to pan. You can also zoom in and out with the mouse wheel. Now you'll notice that there's a slight input bug with mine. As I click down the middle mouse button, it automatically zooms out. Some of you will experience that, some of you will not. Unfortunately, that's just kind of a bug. It's kind of annoying to deal with, but it's also not the end of the world necessarily. You know, you can always just pan it and then zoom back in. Now, confusingly, the zoom controls are reversed, but regardless, that's just how it is. Anyway, we can go down here to our orbit tool, and you'll notice that my cursor turns into a couple of curved arrows, and I can hold down left click and drag in order to pan it around, or rotate it. The reason why it's called orbit is because, of course, we are spinning around a central point somewhere right about, there. So we're picking that central point to rotate around. And this is useful for obviously seeing different sides of a project, as one might imagine. Now, we can always hit escape to cancel any sort of special state that we're in until we get back to the regular cursor, like what I got here. Now, the other way we can navigate, which is generally easier, is by clicking and dragging this cube on top, or in the top right. So as you can see, I'm just clicking and holding down the mouse button, and then moving the cursor around, and I'm dragging it around every which way, and it's showing me the orbit point in the middle, the center point of where I'm spinning everything around, so that I know. And it's green and it's labeled pivot. Once we put the background on it, it's a lot easier to see that word. Now, there's another way to do this. You'll notice that if I mouse over any of these parts of the cube, it will highlight it. So we can actually just click on one of those and bring it directly to that point. We can go down the left, and then we can go to the left edge, left back edge, and then the corner between the left back and bottom. And then we can click on the home in order to bring us back to the original rotation, all that kind of stuff. So that's, again, very useful for navigating around your 3D model. It's something you will take advantage of at least a few times as you're making the bookcase. So again, we'll go over that when it comes to it. I just wanted to make you guys aware of it right now. Now, the way that things are done in many 3D modeling programs, and Fusion 360 is no real exception, is you start with a two-dimensional sort of shadow of what you want. So for example, I'm going to start with a rectangle, and you'll notice that I can select one of these three planes. That is basically selecting what plane we're going to start from. So if we select this one right here, we're drawing from a top-down view, which means it would be like looking at our object if we were looking at it top-down in 2 dimensions, which can be tricky. It might be easier to do it looking at it straight on, so looking at the front of it, or looking at it from the side. But again, same deal. It's always going to be some 2D representation of at least a part of the object until you start building more off of it. So I'm going to start from top down. And you notice it switches its orientation, and then I can just draw like a rectangle. Nothing, too spectacular here, but certainly something that's useful. So now we got a rectangle. Now I was saying that the whole deal about having to constrain it to certain dimensions and make sure everything's in, the proper scale and everything like that. The second part of creating something in Fusion 360 or SolidWorks or anything like that is, well, sketching the dimension. And that is an important aspect. Actually, it's a necessary aspect of creating anything in these programs. Because what it does is it tells the computer, hey, I intended it to be this size. It's going to be this size. Keep it at this size. So, for example, what I'm going to do here is I'm going to go into Sketch and then go into Sketch Dimension and then just click on this left wall here. I click on it once, I'll move the cursor out, and then I click on it again. You'll notice that it brought out this little thing that says 45 millimeters. That's the length of it right now. Now, let's see, I just drew, this is the really handy thing about Fusion, by the way, and others of its kind. Let's say I just drew this rectangle. It's almost kind of a square, with arbitrary dimensions, but I wanted it to be specific dimensions. I was like, okay, I want it to be 150 millimeters by 125 millimeters. Like that is a requirement. Well, you'll notice I only drew at 45 millimeters, but that's okay. I can say, okay, 150. And it will automatically redimension those sides in order to fit my specifications. So I can do the same with this bottom one here. Click once, and it's a click. It's not a click and drag. It's just a click once, and then move the cursor down here, and then click one more time, and set it to be 125. And there we go. It's automatically redimensioned itself to be exactly what I need it to be. Perfect. So now I got this nice two-dimensional rectangle on a plane. Super exciting, right? Now we need to turn this into 3 dimensions. So if we go up here to modify, we can just click on that. And we can say extrude it, oh, I don't know, 120 millimeters. Not 12,000, 120. And then it will automatically resize it. And there you go. Real quick and dirty, easy box prism in Fusion 360. But that is the basic idea behind it. Now, the way you get more complex sketches is now that we have, this 3-dimensional representation of something, we can actually draw additional things on top of it. So let's say we had, our rectangle here, and then we did a circle right there, and then we did an ellipse over here on the side, like that, and just all kinds of stuff. We did like a spline right here. So we created that interesting kind of shape. blah blah blah, you get the idea. Of course, we'll have to constrain these. So let's sketch the dimension. Perfect. And also perfect. And then we'll, of course, sketch the, yeah, well, we'll just do the distance between these two. Well, whatever. We'll turn this into 8 millimeters. And we'll turn this into 16 millimeters. Now you can see between the two of these, what I did is I did the dimension between the center of this circle and the right edge, made it 8 millimeters, and then I made the width of this 16 millimeters. So it automatically constrained itself. And once more, this is just to show you guys, you know, sort of the idea behind something like this, how to make something in this. This is not anything you necessarily have to follow along with. And let's make this 35 millimeters, so it's a little bit squatter. And actually, we're just going to go ahead and delete that. So now, as you can see, we've got a couple more 2D shapes sitting on top of this cube. Now what would happen, specifically if I press pulled this, let's extrude at 10 millimeters. I think I accidentally extruded 103. I think I hit a 3 at the last second. There we go. Now you'll notice that because we separated all that stuff out, it automatically just assumed that it's not something we wanted to extrude. So now we've got a more complex shape just by combining different, you know, two-dimensional shapes. And we can take this even further. Saying, okay, so how big is this? It's 16, right? And then this was 10. So if we sketch the dimension from here to here, and say it's 2.5, whoops. This is part of the trouble sometimes is you have to do math, and sometimes I'm not so hot at that. Oh, right, okay. So there we go. Now it's pretty much exactly centered in this little construction here. So now we can actually take that in, -5, and hit OK. And would you look at that? Now we've created a cut in it. Now, with everything being so strongly constrained and measured, we can ensure that everything is scaled exactly the way we need it to be. So we know that when we go and, you know, mill this or whatever, or 3D print it, there is going to be a 5 millimeter deep and 5 by 11 millimeter square in here, 5 by 5 by 11, which is pretty handy. And like I said before, pretty much necessary for engineering purposes. But, you know, this could be whatever. This could be a CD thrower, a miniature scale CD thrower model. Who knows? I don't know. I just made that up off the top of my head. It's not going to be that. But it could be. You don't know. But that's the basic sort of ebb and flow of Autodesk Fusion is drawing something in 2 dimensions, constraining the measurements, making sure it's got the correct dimensions, and then moving it into 3 dimensions, and then building on top of that, um, and working more and more, and sort of incrementally building upon your design and making it more and more complex. Now, the way we'll be going around making the bookshelf is going to be similar, albeit a little bit different. And you'll see what I mean when we go through it. But at any rate, it's a very useful program. It's very powerful. It takes a little bit of getting used to. But once you get used to it, it's actually kind of neat. But at any rate, I'm going to go ahead and call this a few minutes early, just because at this point you guys are probably still downloading things. It's not quite ready yet, and we don't really have much in the way of material until it is time to get started with Fusion 360. So I'll go ahead and ask the poll questions. We'll bring those up, and then I'll stay on for a few minutes afterwards in case, those of you with internet so fast I'm jealous of you have it already downloaded. You can, ask me questions about getting it set up or something like that in case you need to. Otherwise, we can all go over getting it set up on Wednesday. Why don't we just do that? We'll all go over getting it set up on Wednesday. But regardless, if you guys have any questions about anything, I'll be on for, at least a few minutes after 8, so that you can ask me questions.